Well, my name's Dean Byrne. I'm President and Vice Chairman of Winhyne Energy Group, based here in Cheyenne, Wyoming. Winhyne was formed in June of 2012, and we are now the parent company of Lancaster Wind Systems, based in Nisku, Alberta, Canada, and they have been our R&D company for the last 8.5 years, developing our hydraulic wind turbine and our compressed nitrogen storage system. This process, to develop this process, we kind of studied the wind industry and determined, some of the key issues in the industry, and high maintenance gearboxes was something that really jumped out at us. So we set out to develop a turbine with a little simpler operation and a higher reliability factor. So what our technology involves is we no longer have a generator or a gearbox in the nacelle. That has all been replaced by two high volume hydraulic pumps. These are off-the-shelf items that were being used in the oil and gas offshore drilling process right now. And we've used that to, we use that hydraulic pressure that's generated in the nacelle. We bring that to the ground, and if there's a demand for electricity, then we use that hydraulics to spin the generator and produce electricity. The housing at the very top of the wind tower itself, and then the hub and blades attached to the very center of that. So it is the large housing that you see at the top of every wind turbine.
So your new process would use the same infrastructure, but replace the generator with hydraulic pumps?
Correct. Our technology is currently retrofit technology. We do not produce a new turbine of our own. What we would do is take end-of-life turbines, maybe multiple gearbox failures, or wind turbines that the owner has decided, I want to take down some smaller 750 kW wind turbines and replace them with much larger to repower their wind farm. Those are exactly the kind of wind turbines we're looking to purchase, retrofit them, do a complete quality control check on the blades, the towers, recertify everything, install our technology, and then put those wind turbines back into service. As a result of our presentation at your meeting in Jackson Hole, we did have an introductory conversation with GE, and we're following that up with some conference calls here, in the next few weeks here. We have two technologies that we've developed. The first is the hydraulic turbine that I just described. The second is a compressed nitrogen energy storage system that was designed to work in conjunction with our hydraulic turbine, but can also be coupled with any type of power generation, coal, nuclear, solar, any type of energy generation can be tied in with our system. The way it works with our hydraulic system is when we bring our hydraulic pressure to the ground, if it's the middle of the night and there's no demand for electricity, instead of using our hydraulic pressure to turn electrical generators, we run that hydraulic pressure through some patented devices that we have developed, which converts the hydraulic pressure, and what they are is they're a large diameter, long stroke, but slow moving compression device. So we convert the hydraulic pressure into compressed nitrogen, which we store in a pipeline system. When the demand for electricity increases and we decide to produce power out of our storage system, we bring the compressed nitrogen back at a very controlled rate, and we just reverse the process. Now our nitrogen moves the compression devices, which regenerates hydraulic pressure, and then we turn the generators. So we're currently, our system is still, we're tweaking a few things on that storage system yet. We've demonstrated with a small shop model that we can recover about 65% of our energy. We expect to get in the low to mid 80s with that when we have it completely developed. We have one functional turbine in Nisku that we've been doing all of our testing on, and it really shows what we're really able to do with this hydraulic turbine is generate a lot more power at lower wind speeds. So, a traditional wind turbine that needs, maybe a 7 to 10 meter second wind speeds in order to start running, we'll start producing power as low as 2 meter seconds of wind speed because we offer virtually no resistance to turning. The hydraulic pumps are a radial piston design, and they move much easier than the big gearbox that the traditional turbine has. So we're producing substantially more electricity throughout the entire power curve, but especially at the lower wind speeds. Well, this technology was originally developed in Nisku, Alberta, Canada, just south of Edmonton, and all of our work for the first 8 years was in conjunction with the University of Alberta. Like I say, Winhyne was formed here in the States in June of last year, and we received an invitation to the National Renewable Energy Lab's Industry Growth Forum, where we did a presentation on this technology, and we're continuing to work with NREL on getting their certification on our power curve as well. This technology was actually the idea was first conceived when David McConnell, who is the CEO and chairman of this company, Dave spent 35 years working for ExxonMobil, and a lot of that work was on offshore drilling and production platforms. So this idea of capturing energy off of a rotating shaft with a hydraulic pump was first really thought of for use on offshore platforms and attaching this pump to the main shaft of the drawworks. So it really had its infancy in the offshore drilling business, but the wind industry also was a very attractive energy sector, and Dave continued to move into that. And then that was the combination of those two is where the energy storage system came into play.